Everybody, this is me Vinu Venkatesh again on behalf of Sai Education for Competitive Examinations. So we're going to continue with our lecture on square roots and cube roots. I hope you guys are practicing, because if you're not, then you're really lost. So please don't stop practicing. Please continue with your studies. So let's start with number 14. Which is the smallest number which can be divided by 12, 14 and 21? Greatest 3 figure, greatest 4 figure, and the number to be multiplied to get a perfect square and a perfect cube. So the answer to the first question, you find the LCM of 12, 14 and 21, and the answer is 84. So the answer for the first part is 84. Sorry, I've lost. Yeah. And which is the greatest three digit number which can be divided by 84. So which is the greatest 3-digit figure? It is 999. When you divide by 84, you get an answer of a quotient of 11 with a remainder. So what you do is you simply multiply 84 into 11, that is 924. See what is 84 into 12. It will be a 4-digit number. So the greatest number to be perfectly divisible by 84 is 924, and this is how you find out. Similarly, which is the greatest 4-figure or 4-digit number to be perfectly divisible by 84? Same way, what is first identify the greatest 4-digit number. The largest 4-digit number is 9999. Okay, divided by 84. Find the answer. You will find that it will give you a quotient of 119 with a remainder. So simply multiply 84 into 119. You will get 9996, which is the greatest 4-digit number to be perfectly divisible by 84. If it is 120, you will see that the answer is more than 4-digit. And you know how to do this one. We just discussed it. So this you can do by yourself. The number to be multiplied to get a perfect square and perfect cube. First and foremost, we have found the LCM of 12, 14 and 24. We have got 84. See which factors you have to multiply again, just like what we discussed previously. So I'm not doing that again. Okay, so let's start number 18. Find the value of root 3 up to 3 decimal places. Okay, now let us use some common sense. We know that 1 square is equal to 1. Therefore, root of 1 is equal to 1. Correct? 2 square is equal to 4. Therefore, square root of 4 is equal to 2. Therefore, root of 3 must be between root of 1 and root of 4, isn't it? Because it is root of 1, root of 3, root of 4. This is 1, this we don't know, and this is 2. Therefore, square root of 3 must be between square root of 1, which is 1, and square root of 4, which is 2. That is, square root of 3 must be between 1 and 2. Correct? Why? Because root 3 is between root of 1 and root of 4. 3 is between 1 and 4, no? Therefore, root of 3 should also be between root of 1 and root of 4. Correct? So, let us look at our answer choices. It cannot be A because it's greater than 2. It cannot be B. It can definitely not be C. So, the correct answer must be D, 1.732. And that is the correct answer. They have given another way of doing it, but you can use the way that I showed you. Okay, it's easier and quicker. Now 19, 20 and 21 we have already done similar questions, so you can try it out yourselves. Let us do 22. Find the greatest square number of 5 digits, which is a perfect square. Okay. Now we know that the largest 5-digit number is 99999. Now we can find the square root by a method called the long division method. Okay, in that what you do is, when you're given the number of the square root of which we have to find, you start making the number into pairs from extreme right. So here this will be one pair, this will be one pair, and this number will be by itself. Then you divide it our usual division way. So 3 into 3 is 9, the remainder is 0. Then you will bring down both these numbers, because this is one pair, this is another pair. You will not bring one single number like we do in the normal division. You will bring down both. Okay, so you have 99, which is the new dividend. Here, what you will do is, this quotient that you got here, 3, you will multiply that by 2 and you will get 6. And this number, you will try to find the number that we have to put here, which when multiplied by this entire number will give either the same quotient or less. So here this is 3 into 2 is 6. What number should I put here which is equal to or less than 99? Can I put 2? What is 62 into 2? It is 124. It is greater. So it has to be 1. Therefore this number is 1. So 61 into 1 will give me 61. What is the remainder? 38. Then I have to bring down what? Both 9s. 9 and 9. Not just one 9, because this is the way of doing it. So now I have 3899. Here it should be 31 into 2, which is what? 62. Then we have to find this number, same way what we did. We have to do some trial and error. What is 6? If I take 5, for example, 625 into 5 is 3125. It is very small. 626 into 6 is 3756. 627 into 7 is 4389. So it has to be 626 into 6 is 3756, which is 143. So in our division, we saw that there is a remainder of 143. That means that 99,999 is not a perfect square. So how do we get the perfect square? Simply by subtracting 143, which is the ultimate remainder, from this number. It is 99,856. 99,856, and that's what they have done here. So this method of finding the square root, you will have to understand and practice. I hope it is clear, but if not, please let me know. Now let's move on to number 23. That's also important, okay? Find the smallest number that must be added to 1780 to make it a perfect square. Again, we have to follow the long division method, but there is a slight difference. So 1780, first start putting it into pairs from the extreme right. So 80 is one pair, 17 is one pair. So we find 4 into 4 is 16. You have 1, then you bring down 80 down. So you have 180. Here, what does it become? This into 2. That's what we said. So this becomes 8, and we have to find this number. Okay. 82 into 2 is 164. But 164 is less than 180. That is our normal way of doing. But since we have to find the smallest number that we have to add to this to get a perfect square, we should take the number which is larger than 180. What will be that? That will be 3. So 83 into 3 is how much? 249. This will give you a remainder of 69. In fact, it will give you remainder of minus 69. So we have to add 69 to 1780 in order to make it a perfect square. If you ask me why you do it, it is mathematical and it's just the way of doing it. You just have to understand that. Okay. Alright, so let's move on to number 24. Find the cube root of 2744. Let me show you how to find the cube root. Okay. First of all, we write the cube root like this. Same as a square root sign, but we write a small 3 here. That is the difference between square root and cube root. So when you see a small 3, can you see 3 here? Yeah. That is called cube root. So let us find the prime factorization, or the same method that we use for LCM. So let us divide by 2, because we know that this is an even number. So it's definitely divisible by 2. Find all the factors. You will see that. So 2744 can be written in terms of its factors that we got here. 3 2s and 3 7s. Okay. So we have to find the cube root of this whole thing, which is nothing but 2744 written in the form of factors. So cube root of this into this is nothing but cube root of this into cube root of this. So cube root of 2 into 2 into 2, simple, is its cube root of 8, which is nothing but 2. Similarly, cube root of 7 into 7 into 7 is 7. Okay, you don't even need to multiply this. It is simple. There are 3 2's here. When you take the cube root, definitely has to be only 2. So it is 2 into 7, which is 14. So the cube root of this is 14. This is how you solve such problems. Where is it? There you go, 14. Okay. Now 25, 26, very simple, and we've done something before. So 27, 28 also. Very similar to the problems that we did. So please try it out yourself. Let us stop here for now. We'll continue in our next lecture. So please practice, and see you in the next lecture. Take care and all the best.